Hello, everyone. Welcome to section 4.2. This section is on the natural exponential function. So to start off, let's talk about a very special number. The number e is approximately 2.71828 ... E actually, just like pi, is rational, so it has infinite number of decimal places. But it's one of the most important numbers in mathematics. And since e is a number, we can define what's called the natural exponential function. So, and the way this function is defined is as you would probably expect. It's just f of x is equal to e to the x. Sometimes this is just called the exponential function. It's so important. In terms of exponential functions, this one is the most important. The reason it's so important is because it turns out that e to the x models a lot of natural growth in real life systems and real life situations for things like virus populations or finance, bacterial growth. It turns out radioactive decay, etc. For a lot of different reasons, e is sort of this special number that has this property where e to the x models a lot of growth in natural systems. But let's go ahead and have a little detour. Let's ask, where did it come from? So it turns out that the answer is compounded interest, specifically continuously compounded interest. So we talked about compound interest a little bit in the last section. And Jacob Bernoulli, in, I think, 1683, was thinking about compounded interest as well and asked the following question. An account starts with $1 and has a 100% interest rate per year. So if the interest is compounded once during that year, the value of the account would be $2, right? Because 100% of $1 is another dollar. And so you compound that once, you're going to get a second dollar, you're going to end up with $2 at the end. But if interest is compounded twice per year, So what that means is that you have 50% compound interest each time. You can go ahead and use the compound interest formula that we talked about in the last section. And I think what you'll find is that you end up with $2.25 at the end of the year. So a little bit more, but not too much more. But it's still different from doing it only once, right? And so the question that Bernoulli asked is, what happens if you compound more and more times during the year? So here we compounded once, we got $2. We compounded twice, we got $2.25. You can compound 3 times during the year, 4, monthly, weekly. So what happens if you compound closer and closer together? So to kind of understand how this ties back to E, recall that the formula for compounded interest, you've got A of T equals P1 plus R over N and T, right? And so let's say we have our P was $1, right? Our principal, we invested $1 at the beginning. So it's $1. 1 plus, and then our interest rate was 100%, so that's going to be 1 over, and then the N is the number of times we're compounding per year. So let's just leave that as a variable for now. And then N here again, and then we're only doing this over 1 year, so T is 1 as well. You simplify that a little bit, we get 1 plus 1 over N to the N. Okay, so as N goes to infinity, so as you compound more and more times during the year, the number E is defined to be what 1 plus 1 over N to the N goes to. In other words, as you compound more and more times during the year, the number of, or the amount of money you get at the end of that 1 year is going to get closer and closer to E. So I have a picture, hopefully, that will show up that I can show you a little more what's going on. Nope, it's not going to let me. Okay, let me try this. There we go. Okay, so you can kind of see what's going on a little bit here. This account started $1,000, a little bit different from what we were thinking of, but still about the same. This axis down here is years, and so this green line is they're compounding once per year. And then the yellow, which is a little bit higher, you can see is they're compounding quarterly. And then the magenta slash pink is monthly. And then you can kind of see these curves as you compound more and more times, you get closer and closer to this blue curve. That blue curve is e to the x. Okay. So back to the material that you would actually be responsible for. All that was kind of just background to kind of understand where E came from and like why we care about it. Let's talk about continuously compounded interest formula. Wow, I cannot spell. There we go. Okay, so the continuously compounded interest formula is A of t equals p e r to the t. So where A of t as last time is the amount after 2 years in your account. P is your principal. So how much you put in at the beginning. R is your interest rate per year. And T is the number of years. Okay. So this is the continuously compounded interest formula. And hopefully the background material that I just went through gives you a little bit of intuition as to like where this came from and why it kind of looks like this and like why the E is there. So let's look at an example of maybe using this. So let's ask, how much money do I have in my account that I deposited $300 into it 5 years ago with a continuously compounded yearly interest rate of 4%. So 5 years ago, I put $300 into this whatever savings account, and it's continuously compounded with a yearly interest rate of 4%. And I want to know how much money do I have in that account now. So we'll just the simple application of the formula that we had up there. So we want to know how much money. So we're trying to find A of 5 because T is equal to 5 years here. Our principal is $300. So there's 300. And then E to the RT, R is our interest rate, 0.04 times T is 5. And we can simplify this a little bit, 300 E to the, and I think if you do that multiplication, this turns out to be 0.2. And plug this into a calculator, you get about $366. Okay. Also pretty straightforward to apply that formula. So this section was a lot of just mostly background, introducing you to E and getting you used to looking at that number, because especially if you take calculus, it will pop up again. It is a very important number in math. It is arguably one of the top 5 important numbers, up there with 0 and 1 and pi. So yeah, hopefully this was at least a little bit engaging. I like to think it's cool. I know that's not for everyone though. But yeah, that's E. We will see it again. Let me know if you have any questions on it at all.